Now we have discussed about one new topic, that means bonding in metal complex 2. I will share some so all of you visible my voice clearly. Once again give the clarity.
Yes, sir.
All of you once again give the clarity. Visible or not?
Yes, sir.
Okay. So then all of you go to the mute. Then we can start the class.
Sir, good evening, sir. Ravin, sir, good evening.
So bonding in metal complex. So that means that is give the information about which type of information are given. That bonding metal complex 2 is give information about the so for example you take one element, for example you take the carbon. What is the atomic number of carbon? 6. Okay, generally we can write the details of this carbon 1s2 2s2 2p6 like that only. Okay, so this is not 2p2. This is not enough information for this element. Okay, we can get the complete information of this element. We can apply some quantum numbers. Okay, apply some quantum numbers that explaining which type of properties are in that quantum number, that is can explain in this block and in this chapter. That is what bonding in metal complex 2. So here we can apply the which type of quantum numbers are applicable here. The first one is the major quantum number is the principal quantum number. The second one is the azimuthal quantum number. Azimuthal quantum number. And the third one is the magnetic quantum number. Third one is the magnetic quantum number. Fourth one is the spin quantum number. These 4 quantum numbers we can apply in this particular element. That is give the full information about that. Full information about that. That what is the meaning of full information about that? We can explain in this chapter. Okay. So what is the information about the principal quantum number? Principal quantum number can give the information about, that is can represent n. The principal quantum number can represent what is the word n. N is equal to 1. The first valency means electron is present in first valency. N is equal to, that is the second valency, or n is equal to 3, that is the third valency, like that. That means nucleus is contained first sphere, that is 1, second sphere, third sphere, fourth sphere. That means the principal quantum number is explain what is the sphere, means what is the valency of that orbit is present in that orbital. Okay, that is can explain the azimuthal quantum number. So principal quantum number. Then the azimuthal quantum number is explained, that is can represented the, what is the word? The azimuthal quantum number can represent the word is the what? L. Okay, L. Okay, represent the word is the L. Azimuthal quantum number can represent the L. So L is equal to 0. There is no orbital angular momentum of this. L is equal to 0. There is no orbital angular momentum. That means that is electrons are present in s orbital. L is equal to 0. You can apply the magnetic field in that orbit. Okay, there is no orbital angular momentum takes place. That means what? That is can represent the s, means the electrons are enter into the s orbital. L is equal to 0. Electrons are enter into the s orbital. Okay, L is equal to 1. Electrons are enter into the p orbital. L is azimuthal quantum number. L is equal to 1. That is enter into the p orbital. Okay, in that what is the angular momentum of p orbital? That means that is the electrons are present in +1 0 -1, +1 -0 -1. That means we can apply the magnitude of in that orbital. The orbital angular momentum is given, that is can represent like this, or p orbital is contain 3 suborbitals, they are px, py, pz. Okay, this is the information about in these two quantum numbers are given like this. Okay, means the principal quantum number, the electrons are present in which orbit, okay, which valency, which are valency, in that valency are contain different orbits, that valency are contain s orbit, p orbit, d orbit, or f orbit. Electron is present which orbit, and what is the angle azimuthal quantum number of that. So in L is equal to 1, that is electron enter into the p orbital. What is the angular momentum of, means what is the orbital angular momentum of p orbital, that is +1, and electron present probability is there in electron present in +1 in this orbit, or in this orbit, or in this orbit. Okay, in general. Then the second L is equal to 2, what is the, that is indicate the d orbital. L is equal to azimuthal quantum number, L is equal to, that is indicate the d orbital. Then L is equal to 3, that is the f orbital, like that. That means azimuthal quantum number are give the information about electrons are present in which orbit, and what is their angular momentum, what is their angular momentum. Okay, they explain this. Okay, and these two quantum numbers are not given for complete information about that particular element. So take any element, not only carbon. Okay, then the third is the magnetic quantum number. Magnetic quantum number means we can apply the magnitude of that. So the electrons are the orbital angular momentum is given, that is represent the m. Okay, means L is equal to 0, there is no magnitude, there is no orbital angular momentum. L is equal to 1, but the angular momentum is what, +1 minus 0 minus 1. L is equal to 2, that is a d orbital. Okay, like that. Okay, +2 0, this is a +2 +1 0 -1 -2, that can represent. This is how can we give this, that is called what, orbital angular momentum. That means we can apply the magnitude of or magnetic field of in that orbit, that is can give their suborbitals, that is can given for the magnitude of that. There is no magnetic field of in that orbit, these are not given for that information. Okay, that is can given the, not only this, spin angular momentum also, orbital angular momentum and spin angular momentum also given for the apply the magnitude of in that orbit. We can apply the magnitude of in that orbit, that is can split into or give into the some different orbits, and means electron finding probability is given for that, electron finding probability. Okay, like that. Okay, give information, complete information about that. Next one is the fourth one is what, spin quantum number. Spin quantum number, what is the given information about the spin quantum number in that orbit, one orbit is there. Okay, for example in s orbital are contain 2 electrons. S orbital are contain how many electrons, 2 electrons. In that 2 electrons, what is their representation and what is their orientation, what is the spin of electron, what is the spin of electron, that is can give information about the spin quantum number. Spin quantum number, it means for example here electrons are present like this, one is clockwise, one is the anti-clockwise, one is the plus of orientation, one is the minus of orientation, plus of minus of. Okay, like that. This is can given information about the spin quantum number. Based on these 4 quantum numbers, based on these 4 quantum numbers, now we can discuss about their explanation or properties of in this conclusion of this chapter. So what happened here? Okay, so here so in general, you can apply these 4 quantum numbers. We can apply the 4 quantum numbers: principal quantum number, azimuthal quantum number, and magnetic quantum number, and spin quantum number. What is information is give? First, we can write the any element. We can write the what configuration first. Okay, configuration is given the term. Means what? Term is nothing but what? So I will explain. Term is given for status or state. state is given for the microstates. Okay, how to give the configuration into the term here? Inter-electron repulsion takes place. What is that? Inter-electron repulsions are takes place. What is the mean by inter-electron repulsions? Electrons are moving around the nucleus and itself also. Electrons are moving the nucleus and itself also. In that condition, some repulsions are occur or some attractions are occur. That is called what? Inter-electron repulsions. That is called what? Inter-electron repulsions. Okay, some electrons meet in one place, meet in another place. In that condition, attraction is occur and repulsion also occur. So in that condition, inter-electron repulsion is give the terms. Okay, terms can give the state of the state means microstate. How can you give that? So we can here apply the total orbital angular momentum, that is can give the L, total orbital angular momentum, and total spin angular momentum. Total spin angular momentum. S is nothing about total spin. Capital S is nothing about total spin angular momentum. Capital L is nothing total orbital angular momentum. Means L is coupled with the S. L is coupled with the S. Then give the state. Okay. Then the state is can give the microstate. How can you give the microstate? Means electron is present or means you can indicate the electron in that particular orbital, which orientation, how many probabilities are there, that is can give the microstates. Okay, we can explain this. This is called what? Zeeman effect. That is called what? Zeeman effect. Zeeman effect can give the, who is scientist, that microstate. What is the meaning of microstates? So first we can explain the microstate. State, term, configuration. Or configuration is give the term is give the state is give the microstate. How can you give the this? Apply the 4 quantum numbers. You can apply the 4 quantum numbers. Which quantum numbers they are? Principal quantum number, azimuthal quantum number, and magnetic quantum number, and spin quantum number. We can apply the 4 quantum numbers. You can explain each and every element of the periodic table. Each and every element of the periodic table, we can give the complete explanation of about in that element. So based on that, here we can calculate the microstate for very for this. LS coupling important, microstate also important. How can you calculate the microstate? What is the mean by microstate? Microstate means, for example, p orbital is contained 2 electrons. So for example, p orbital is contained 1 electron. P orbital is contained 1 electron. P1 configuration. Okay. Generally, we can write the configuration what p orbital are present here. Okay. Not only present here, the probability is there. That is present here also. Not only that is probability is here also. That means what? Electron present here. Electron present here. Which orientation? Different orientation, like this. Here present like this, here present like this. Okay, means this is called microstate. Or electrons are present in this orbit. Or electrons are present in this orbit. What is the orientation? This is like, one is a clockwise, one is a anti-clockwise. Or another probability also is there. Electron present in this orbit. Electrons are present in this orbit. What is the orientation? That is also different orientation, like anti-clockwise, anti-clockwise. That means p orbital is contain 1 electron. That 1 electron can represented. How many probabilities are there? How many possibilities are there? 6 possibilities are there. Get the point? P orbital is contain 1 electron. P orbital oka electron unte. What is the probabilities? We can write their positions like here, like this, or like this, like this, or like this, like this, or like this. Okay, means total how many microstates are there? 6 microstates are there. That means 6 possibilities are there. p orbital is contain 1 electron. 6 possibilities are there. Okay, how can you calculate the microstate? Though this is the p1, for example, p2 configuration, p3 configuration, different configurations are there. Different configurations are there. How to calculate the microstate? How to calculate the microstate? Simple equation is there. Simple equation is there. Microstate is equal n factorial is divided by r factorial and n minus r factorial. Okay, what is the equation? Again, it's a very important equation. Microstate is equal n factorial is divided by r factorial into n minus r factorial. So what about n and what about r? Here n is equal to double of the orbital. Okay, r is equal to number of electrons. R is equal to number of electrons are present. What is the meaning of double of orbital? For example, electron is present in p orbital. Electrons are present in p orbital. What about n? N value is what? Means what? P orbital means what is the azimuthal quantum number of p orbital? Azimuthal quantum number of p orbital L is equal to 1. Okay, electron present probability in the what is the angular momentum of p orbital? That is a +1, 0, -1. Means electron present probability +1 is possible, 0 is possible, -1 also possible. That means 3 orbitals. P orbital is contain 3 suborbitals. Double means another 3 orbitals. 3 plus 3, 6 means electrons are present in p orbital. What is the n value? N value is the 6. Okay, n value is the 6. Okay, I will give simple example for that. What is the example? For example, electrons are present. Okay, this is the nucleus. This is the sphere. This is the nucleus. Electron finding probability. For example, in this position is there. In this position. Okay, so positions are there. This position is the +1. And the electron finding here, or this position, that is a 0. Or this position, this is the -1. Electron is surrounded by in this nucleus. Electron are surrounded like this in this nucleus. Okay, so in all places are not find the electron. Some places are find the electron. They are what? This +1, 0, -1. That means electron find here, or electron finding here, or electron finding here. These 3 positions. Again come into in this place the electron, again finding here. That means one complete circle. One electron is take the complete circle. That is the double, means here to here and here to here. That means we can take the double of the orbital. That means n is equal to 6 for p orbital, n is equal to 2 for s orbital, n is equal to 10 for d orbital. Why? D orbital is contain 5 suborbitals. D orbital is contain how many suborbitals? 5 suborbitals. Means electron finding capacity. D means L is equal to 2. That means +2, +1, 0, -1, -2. 5 probabilities are there. This is the nucleus. Electron finding here. This is a +2. This is the +1, 0, -1, -2. Again -2, -1, 0, +1, +2. That means double of the orbital. We can apply in this equation. We can calculate the microstate of the different configurations. That is what is the configurations. What is the microstates, and what about the LS coupling? That is important. LS coupling is very important. And how to calculate the microstates? What about the microstates? We can explain here. Okay, so we can apply that equation. Another equation also is there. Microstate is equal to 4 plus 4L plus 2 factorial. 4L plus 2 factorial is divided by Q factorial 4l plus 2 minus 2 factorial. Okay, that is another equation. Okay, or another equation means n factorial is divided by r factorial into n minus r factorial. This is a simple equation. Both equations are calculate the microstates. We can use the both equations. These equations are this equation. So we can apply these equations and calculate the microstates of various configuration. So here one question is coming for the examination. Here one question is coming for the examination. Okay. So what is the equation? That is the equation. For example, p orbital is contained. P orbital is contained to electrons. P orbital is contained to electrons. What is the probability is there? What is the probability? How many microstates? How many possibilities are there? In that two electrons are present in that p orbital. Two electrons are present in that p orbital. How many possibilities are there? That is called what? Microstates. How many possibilities are there? Example, microstate is equal to, what is the equation here? N factorial is divided by r factorial n minus r factorial. Okay. What about n value here? N is equal to 6. R is equal to what? 2. We can apply all values that. Okay. N is equal to 6 means 6 factorial is divided by. Okay. R means what? Number of electrons. How many electrons are there? 2 electrons. That means 2 factorial into n means what? R minus 2 factorial. Simplify this equation. 6 factorial divided by 2 factorial into 4 factorial. That is the equation. 2 factorial into 2 into 4 factorial. This is equal. What is the mean by factorial? Is 6 into 5 into 4 into 3 into 1 is divided by maximum multiply to minimum multiply. Factorial means maximum multiply to minimum multiply. That means 6 factorial means 6 into 5 into 4 into 3 into 1. Then 2 factorial means 2 into 1. Then again 4 factorial. 4 into 3 into 2 into 1. So here 4, 3 to 1. Here 4 through T1 gets cancelled. Here 2 is there. Here 3, 6 is there. 2, 3, 6. Means here what is the remaining multiples are there? Here 3 and 5 is there. 3, 5 15 microstates are there. The P2 configuration means p orbital is contained 2 electrons. How many microstates are there? 15 microstates are there. That means you can write our probabilities, our possibilities are in that 2 electrons, our orientation or representation in that orbit. How many possibilities are there? 15 possibilities are there. Okay. Means what? Once again we can calculate that. Okay. After substitute the all values, we get which values for that? Okay. 6 factorial is divided by 2 factorial and 4 factorial. This is a conclude point. So here what 6 factorial means 6 into 5 into 4 into 3 into 2 into 1 is divided by 2 factorial means 2 into 1. 4 means 4 into 3 into 2 into 1. This 4 cancel. Okay. 4, 4 cancel. 3, 3 cancel. 2, 2 cancel. 1, 1 cancel. Here 2 is there. Here 6 is there. 2, 1 ja, 2, 3 ja. Remaining what? 3 into 5. 3 into 5 is equal to 15 microstates are there. 15 microstates are there. That means 15 possibilities are there. For example, in the P3 configuration, P4 different configurations are there. In P3 configuration, how many microstates are there? P3 configuration, how many microstates are there? In the P3 configuration is 20 microstates are there. Okay, we can calculate that. P3 configuration means n factorial is divided by r factorial n minus r factorial means 6 factorial is divided by r means 3 factorial. N means 6 minus 3 factorial, that is equal to 6 factorial by 3 factorial, 3 factorial. Okay. So 6 factorial ante what? 6 into 5 5 into 4 into 3 into 2 into 1 is divided by 3 factorial. 3 into 2 into 1. Again 3 into 2 into 1. 3 to 1, 3 to 1 gets cancelled. Here 3 is there, here 2 is there. Okay. Here 2 is there, here 4 is there. 4 2 ja. 2 5 ja. Here, what is the final value? 2 is there. 5 is there. Again 2 is there. 2 5 2. 2 5 ja 10. 10 2 ja 20. 20 microstates are there. Means in the P3 configuration, how many microstates are there? 20 microstates there. What is meaning of that? Okay, p orbital is contain 3 electrons. P orbital is contain 3 electrons. How many microstates are there? 20 microstates. I will show that. Another, we can put the another slide. Not only if 15 members are joined in the class. Just wait, I will give the another slide like this. Okay, here observe here P1 configuration, 6 microstates are there. In the P2 configuration, D1 configuration, so complete picture is there here. Okay, so we can calculate the microstates. P1 configuration, 6 microstates are there. D2 configuration, 45 microstates are there. D1 configuration, 10 microstates are there, like that. What is the mean by microstates? Okay, the how many possibilities are there, how many probabilities are there in that electron, like this. Observe here. So I will write one by one. You can take any configuration. You can take any configuration, D2, D3, D4, D5. Okay, I will write the how many microstates are there. Okay, you can means cross check that. Okay, I will write complete data of microstates. Okay, complete data means what? For example, in P1 configuration, 6 microstates are there. In P2 configuration, 16 microstates are there. In P3 configuration, 20 microstates are there. Okay, 20, not so P4 configuration, again 15 microstates are there. P5 configuration, again 6 microstates are there. So here you can find one point. What is the point? P1 configuration, 6 microstates. P5 configuration, 6 microstates. P2 15, P4 15. That means P1 properties are similar to P5 properties. P2 properties are similar to P4 properties. P3 is a half fill, complete half fill configuration. That is give the different property. This is nothing about what? Whole formalism. That is nothing about a whole formalism. This is nothing about p orbital microstates. What is that? P orbital microstates. These are the p orbital microstates. Okay. The p orbital is contained. P orbital is contained different electrons. Different electron means p orbital is contained one electron, means P1 configuration. How many microstates are there? 6 microstates are there. In P2 configuration, how many microstates are there? 15 microstates are there. What is the microstates? Electron presenting. And electron మనం రాసే ప్రాబబిలిటీస్ ఆర్బిటాల్లో. ఈ ఆర్బిటాల్లో 2 ఎలక్ట్రాన్స్ ఉంటే 15 టైమ్స్ రాయొచ్చు. ఈ ఆర్బిటల్ ఒక ఎలక్ట్రాన్ ఉంటే 6 టైమ్స్ రాయొచ్చు. ఈ ఆర్బిటల్ 3 electrons are there, write the 20 possibilities are there. Again P4 15, again P5 6 is there. This is nothing about the complete information about p orbital. So next, what about the d orbital? What about d orbital? Okay, the d orbital, for example, we can calculate the d1 configuration microstates. We can calculate the d1 configuration microstate. D1 configuration. What about n here? N is equal to double of the orbital. D means electrons are present. D orbital means L is equal to 2. L is equal to is nothing about d orbital. Electrons are present in d orbital. That means what is the azimuthal quantum number? 2. Means we can apply the magnetic field of in that orbital. What is the orbital angular momentum? +2, +1, 0, -1, -2, like that. The electron present probability +1, +2 orbit, +1 orbit, 0 orbit, -1 orbit, and -2 orbit. 5 probabilities are there. Again, Double means again 5. 5 plus 5 what? 10 means d orbital is contained electron. That is 1 electron or 2 electron or up to 9 electrons or 10 electrons. What is the n value? N is equal to 10, is always 10. Okay. What about r value? R is equal to number of electrons. R is equal to number of electrons. Based on in this, okay, we can calculate the d1 configuration. Means d orbital is contain 1 electron. What is the microstates, or how many microstates are there? Okay, we can calculate that d1 configuration. So here microstate is equal to n factorial by r factorial into n minus r factorial. What about n is equal to 10? R is equal to 1 electron. Okay, means what? 10 factorial is divided by r means 1 factorial. What about n? Again 10. How many electrons are there? 1 factorial. That is equal to 10 factorial is divided by 1 factorial into 9 factorial. Okay, so this is the final equation, the final conclusion. Then 10 factorial means 10 into 9 into 7 into 8 into 7 into 6 into 6 into 5 into like up to 1 is divided by 1 means 1. 9 means 9 into 8 into 7 into like that. Okay, so 9, 8, 7, 1, 9 complete cancel. What is the remaining? 10 by 1, that is 1, 10. What is the microstate? 1 is the microstate, 10 is the microstate. Okay, that is there here. You can observe that. Okay, that is there here in the d1 configuration. Okay, d1 configuration. Just wait. I will observe that. I will show that microstate very very important for this. Just wait. Okay, in the d1 configuration, see, observe here, d1 configuration, n factorial is divided by r factorial into minus r factorial. It is 10 factorial. 10 factorial. 10 minus 1 factorial. Okay, like this. Okay, so how many is there? 10 microstates are there. Okay, 10 microstates are there. 10 microstates are there. Okay. And d2 configuration. What about d2 configuration? In the d2 configuration, how many microstates are there? 45 microstates are there. That means d orbital is contained 2 electrons. D orbital is contained 2 electrons. How many microstates are there? 45 microstates are there. What is the equation for that? That is the equation. 10 factorial is divided by 2 factorial into 8 factorial. Okay, 10 factorial means 10 into 5 into 10 into 9 into like that. Okay, so observe here, 10 into 9 into 8 into 7 6 or 2 factorial means 2 into 1, again 8 factorial. Complete means simplify that, total 40 microstates are get microstates. Like that you can write the different configurations. Different configuration means for d1 configuration 10 microstates are there. In the d2 configuration 45 microstates are there. D3 configuration 120 microstates are there. D4 configuration 210 microstates are there. In the D5 configuration 252 microstates are there. Okay, these are the means d orbital is contain 1 electron, 10 possibilities are there. D orbital is contain 2 electrons, 45 possibilities are there. D orbital is contain 3 electrons. Okay, what is the possibilities is there? Just wait. What is the possibility is there? 120 possibilities is there. 120 possible. 3 electrons are there. Then 4 electrons are there. 210 possibilities are there. 5 electrons are there. 252. Again, repeat again. D5, then D6. D6 again 210. D7 again 120. D8 again 45. D9 again 10. That means D1 is the less than half filled configuration, D9 is the more than half filled configuration. Means D1 and D9 are given, D1 and D9 are given same microstates, are given same microstates. That means D1 is the half filled configuration property is similar to D9, more than half filled configuration property are similar. That is called what? Whole formalism. Okay. D2 is contain 45 microstates. Again, D8 also is contain 45 microstates. Okay. D3 is contain 120 microstates. Means what? D orbital is contain 3 electrons. What is the microstates? How many probabilities are how many possibilities are there? 120 times you can represent the target electron. D4 is the 210. What is the same more than half filled confident? D6, D3, D7, D2, D8, D1, D9, D5 is the separate, that is 252 microstates. Okay. This is complete picture about the what is the microstates and how to calculate the microstate. How to calculate the microstate. Okay. Then after that we can explain the what is the orbital angular momentum and what is the spin angular momentum. What is the spin angular momentum? The orbital angular momentum is give the information about what is the term is used. What is the information? What is the term is used in, just wait. Orbital angular momentum is new. What is the term is used? Then spin angular momentum is give which what is the electron representation of that. Okay. So now we can discuss about orbital angular momentum. Orbital angular momentum. How can you explain that? Means orbital angular momentum is write the capital L. Write the letter is the capital L. Total orbital angular momentum. Okay. We can apply the magnitude of in that orbit. That is give the term or L value. That is can give the inter-electron repulsions or occur. That is occur the inter-electron repulsions. How can you calculate that? Capital L is equal. Capital L is equal to L1 plus L2 and L1 plus L2 minus 1, L1 plus L2 minus 2, L1 plus L2 minus 3, like that. Okay. So based on this, give the total orbital angular momentum. Okay. We take one configuration and we can calculate the total orbital angular momentum. That means electrons are present, one electron to n electron. Sometimes orbits are contain one electron, sometimes two electrons, sometimes three electrons, sometimes four, six, up to number of electrons are present. Number of electrons are present, we can addition of all electron angular momentum. That is give the total angular momentum of orbital. Okay, means individual electron give some angular momentum. You can in individual can addition of all electron angular momentum. That is can give the total orbital angular momentum. So means what? One equation we can write the one equation. Total orbital angular momentum capital L is equal to the summation of n is equal to 1 to n. N is equal to first one electron to n electron. Number of electrons are present. Okay. Then L n. This is the equation for calculate the orbital angular momentum equation. What about this summation of n elements? L1 plus L2, comma L1 plus L2 minus 1, so on. Finally, L2 minus L1, and finally L2 minus L1. Okay, we can give the different configurations. Different L value is given. Different L value is given. Different terms are used. Different terms are used. Okay, different terms are used. That is can give the states of the means LS coupling. Give the state. Okay, states are give the microstates. Okay, you can calculate the microstates. Now, which type of terms are used? Which type of terms are used in this different configurations, different then calculate that. Okay. One equation is there. What is the equation? First we can write the configuration. For example, I will put the another page that is the information about R, not explained. Just wait.
అని
Just wait.
తీసుకురాపో అక్కడ లోపల ఉంటాయి. నీ ప్యాడ్ ఈజీరా.
Just wait. That is not paper, another paper is there. This is the orbital angular momentum. Orbital angular momentum, that is can give the L values. Capital L values is nothing about orbital angular momentum. So capital L is equal to 0.
వేరే
After
పెన్
calculate the total orbital angular momentum,
Yeah,
that is
Benny.
can give the 0. What is the term used? S term. So L is equal to 1. What is the term used? P term. L is equal to 2. What is the term?
ఏదో ఒకటి
D term. Okay. L is equal to L is equal to 3 means what here? L is equal to 0. What is the term? S term. L is equal to 1. What is the term? P term. L is equal to what is the term? D term. L is equal to 3. What is the term? F term. L is equal to 4. What is the term? G term. L is equal to 5. What is the term? H term. So on. This is the total orbital angular momentum give the information. Okay. So we can apply the different configuration, give the different L values. With the different values, L values, we can conclude the what is the angular momentum of that orbital and what is the term is used. What is the term is used. So take one example. What is the example or one configuration? What is the configuration? For example, P2 configuration. P2 configuration. We can find out the L value. L value means total orbital angular momentum. We find out. How to find out that? What is the L? L is equal to L1 plus L2. L1 plus L2 minus 1. L1 plus L2 minus 2. This is the equation. Okay, what about the L1? L1 is equal to what? L1 is equal to L1 is equal to 1. L2 is equal to also 1. What is the how why the L1 is equal to 1? Why L2 is equal to 1? That means L1 is equal to means p orbital is contained 2 electrons, means 2 electrons are present in p orbital only. Get the point here. 2 electrons are present in p orbital only. Okay, means both electrons. This is the first electron of p orbital. This is the second electron of p orbital. Get the point here. Very very important point. First electron of p orbital. So first electron of p orbital. Okay, that is one what L is equal to 1. 1 means what? P orbital. Azimuthal quantum number of p orbital 1. First electron present in 1 under p orbital. Second electron also present in p orbital. That is also 1. First electron present p orbital. That is 1. Second orbital also present in p orbital. That is also 1. Okay. Now, what is the equation? L1 plus L2 means 1 plus 1 is equal to how much? 2. Capital L is equal to give here. Okay. Next, second means the continuation. L1 is equal to 1. L2 is equal to also 1. Minus 1. 1 gets cancelled. L is equal to 1 is given. Next, in this equation, what is the equation? L1 is equal to 1. L2 is equal to 1. Minus 2. 1 plus 1, 2. 2 gets cancelled. L is equal to 0. That means in the P2 configuration, what is the L values are given? The given for L values are L is equal to 2, 1, 0. L is equal to 2. What is the term is used? D. L is equal to 1. What is the term used? P. L is equal to 0. What is the term used? S. Means in the P2 configuration is how many microstates are there? 15 microstates are there. In that 15 microstates, we can use the terms. What is the terms are used? These terms are used. Which terms? D term, P term, S term. Okay. In that 15 microstates, we can use the terms are D term are repeated sometimes, P term are repeated sometimes, and S term also repeated sometimes. That means that is the what orbital angular momentum of p orbital, that is P2 configuration. What is the configuration? P2 configuration. Okay, like that. And what about D2 configuration? That is also similar. We can observe here some configurations are there, and that is can explain. We can vectorially also. The orbital angular momentum we can explain vectorially. That means what? Diagrammatically we can explain. How to explain that vectorially? That is also one is there. Okay. So this is the orbital sphere. This is the nucleus. Okay. Can find out the electron probability in p orbital means we'll find out the probability +1, 0, -1. So here, how to find out that here +1? Electron find out in this position, that is +1. Electron find out in this position, that is 0. Electron find out in this position, that is the -1. Electron find out this position or this position or this position. Means electron is surrounded by the nucleus. We can find out some positions. That positions we can give the numbers. We can find out this position, that is +1. You can find out this, that is a -0. Find out this, that is a -1. Okay, like that. Vectorially, we can explain that. How to explain that? Okay. So let here explain data is there. We can explain that data. Okay, means P2 configuration like that here. Okay, P2 configuration means your L1 is equal to 1, L2 is equal to 1. Total L is what? 2. L is equal to. So the term is the D term. L is equal to, that is the D term. Here what? L is equal to 1, L is equal to 1. But here electron finding is in which position? 0 position. You observe in this diagram. Okay? Like that. Means what? Electron. Observe. You can observe this diagram. You can observe this diagram. So here what about L1 is equal to 1? That is, find out this position. L2 is equal to also in this position. What is the capital L? L is equal to 1 plus 1, that is 2. Using the term is D. Okay. Next diagram. You can observe this diagram. L1 is equal to 1, like this. This is a +1. Another electron find out the L is equal to 1, but that is find out in which position? 0 position. But that is not count for this. What is the L value here? L value how much? What is the third diagram? Third diagram also is there. What is that? L1 is equal to this, means +1. L2 is equal to -1. Electron finding probability 1 is the above below the plane. +1 -1 gets cancelled. L is equal to 0. You can explain the vectorially also. You can explain the vectorially also. That is this diagram. Okay. What is the diagram? This is means L plus L, that is 2. L 1 plus 0, that is 1. This is given the 0. Okay, so can give the L is equal to 2, that is the term is D. L is equal to 1, that is term is P. L is equal to 0, the term is S. Okay, in the P2 configuration we can use the 3 terms. Okay, can explain the mathematically or we can explain the diagrammatically. That is called what? Vectorial representation of P2 configuration, vectorial representation. What about the D2 configuration or D electron? D also similar. D also similar. For example, in D2 configuration, for example, in D2 configuration, D2 configuration. What about L here? L is equal to 2. Okay. First electron is present at D orbital. Second electron also present in D orbital. Okay. What about capital L is equal to L1 plus L2. Okay. We can write the equation. We can conclude here. First electron present D orbital means L1 means first electron present in D orbital. Second electron also present in D orbital. What about capital L4? Capital L4 means what is the term? G term. So like that, so many different terms are there. Okay, we can use the different terms. Like here, the D2 configuration also is there. You can observe here, D2 configuration also is there, clearly is there. Don't means what confuse here. So D2 configuration also is there. In the D2 configuration diagrams, you can observe the diagrams. First, we can find out the values, then diagrammatically. What is the mathematically? L1 plus L2 means 2 plus 2 is equal to 4. L1 plus L2 minus 1 means 4 minus 1 is equal to 3. L1 plus L2 minus 2 means 4 minus 2, that is equal to 2. Okay. L1 plus L2 minus 3, that means 4 minus 3 is equal to 1. Okay. L1 plus L2 minus 4 or L2 minus L1, that is give the 4 minus 4 is equal to 0 or 2 minus 2 is equal to 0. That means in the D2 configuration, what is the terms are used? Total 5 terms are used. What is the L value? L is equal to 4 is we can get, and 3 is get 4, 3, 2, 1, 0. Total 5 terms are used. What is the microstates or how many microstates are D2 configuration? In the D2 configuration, how many microstates are there? 45 microstates are there. D2 configuration, 45 microstates are there. In that 45 microstates, we can use the terms or these terms. Okay. L is equal to 4 is the one of the term. What is the 4 means? What is the L value? Means L is the G. What is the 3? L is equal to 3. What is the term? F term. L is equal to what is the term? D term. L is equal to 1. What is the term? P term. L is equal to 0. What is the term? S term. That means in that 45 microstates are represented or means represent the 5 terms. We can give the name, give the 5 terms. Okay. G term are repeated sometimes. F term are repeated sometimes. G is repeated sometimes. P is repeated sometimes. S also repeated sometimes. Total 45 times are repeated in this all 5 terms. Total 45 times are repeated these 5 terms. Okay. So that is can explain this. Mathematically we can explain this. Here diagrammatically also is there. You can observe this diagram clearly is there. Don't confuse that. Clear diagram is there. Okay. What is the clear diagram here? Okay, you can observe this. Okay, L just zoom is that you can observe the diagram. Okay? L1 is equal to L1 L2 is equal to, that is the 4. L1 is equal to L2 is equal to, that is the dihedral is there. Okay, explain the diagram also. Again, the third diagram. Okay, vertical is there, one horizontal is there. Here both are vertical. First diagram is both are vertical. Second is one vertical. Second one is the dihedral. Okay, the third diagram. One is vertical, one is horizontal. Here fourth diagram. One is the vertical, one is the diagonally below the plane. Okay, in the fifth diagram, one is the above the plane vertical, one is the below the plane vertical. That means what? electron finding probability is there like that. Okay, just wait. Okay, so in the d orbital, okay, what is the probabilities are there? What is the apply the magnetic field of d orbital? What is the angular momentum of the orbital? That is L is equal to 2 means plus 2 plus 1 0 minus 1 minus 2. Okay, 5 possibilities are there. They are drawing vertically vectorially here. So you can find out the d orbital contain the means surrounded by the nucleus. D orbital is there. In the d orbital are contained 2 electrons. The 2 electrons we can finding the possibility is this is one position, that is the plus. This is the one position, that is the plus 1. Diagonally plus 1. This is the another position, that is the 0. This is the another position, that is the minus 1. This is the another position, that is the minus 2. Okay. Find out the electron probability finding in this circle, means in this vector or in this circle orbit, in this orbit. You can find out 5 possibilities are there or 5 probabilities are there. That is the plus 2, plus 1, 0, minus 1, minus 2. Okay, that is can L1, L2, L1, L2, L1, L2, L1, L2, L1, L2. Both are like this. Both are in this addition. Here, this is 2, this is 1. 1 means diagonally. You can observe diagonally means addition of 1. Electron present in plus 2 and plus 1. That is L is equal to 3. Electron present in plus 2 plus 2, that is 4. Electron present in plus 2 0. Electron present plus 2 0 plus 2 and 0. That is called what? L is equal to electron present in plus 2 minus 1. Present in plus 2 here this and minus 1. That is what L is equal to 1. Electron present in plus 2 and minus 2. That is called 0. That means the D2 configuration you can find out the 5 terms. We can write the 5 terms. They are what? They are what? L is equal to 4, 3, 2, 1, 0. This is the G term, F term, D term, E term, S term. The repeated terms are there. Repeated terms are there. This is nothing about the orbital angular momentum. This is very, very important. What about the spin angular momentum? Total spin. How many electrons are there? And what is the spin of electron? What is the spin of electron? You can observe this P2 configuration. Okay. Next, spin coupling is there. P2, D2 configuration. Different configurations are there. Okay. Then spin orbital angular momentum. So joining only 13 members only. Okay. So this spin orbital angular momentum. Spin angular momentum, total spin angular momentum. That means spin of the electron. Spin of the electron. What is the spin of the electron? For example, electron is present. Three conditions are there. First condition: two electrons are present in same orbit. Second condition: two electrons are present in different orbits. Third condition: three electrons are present in different orbits. Okay, three electrons are present in different orbits. What about the spin? Two electrons are present same orbit. Here S is equal to 0 always. S is equal to 0. Okay. Two electrons are present to different orbits. Means here what? Here both are in clockwise. That condition 1. Both are, one is clock, one is anti-clockwise. That is the 0. One is anti-clock, one is clock. That is the 0. Both are in anti-clockwise. That is the 1. That is minus 1. That means two electrons are present in two different orbits. What is the spin? 1, 0, 0, minus 1. Okay. Two electrons are present in same orbit. Always S is equal to 0. three electrons are present in three different orbits. What about the total spin angular momentum? So this is the probabilities of electron. Okay, like three electrons are clockwise. In that condition, 3/2. Two clockwise, one anti-clockwise. In that condition, minus or 1/2. Okay, means three electrons are present in three different orbits. The spin orbital angular momentum is always uh, that is 3/2 and 1/2. Two electrons are present, S is equal to 1 and 0. Same orbital present, S is equal to 0, like this. So based on this, we can give the total orbital angular momentum. Okay. So now today we can stop the class. Okay. Continue tomorrow. What is the LS coupling? That is a very important. LS coupling is the very important. Okay. Today we can stop the class. Tomorrow I think my class, the Inorganic class is the 9 a.m. Okay. Join all of you. Now stop the class.
Sir, please share the notes. No?
Okay. Any doubt?
Sir, please share the notes.
So now I will stop the class. Okay. Understood all of you?
Yes, sir.
So all of you leave the class.
Yes. Thank you.
Last తిప్పినాం ఫస్ట్ తిప్పను Nice.